Hey folks, this is Shane from Performance EV. Today we're working on our open source inverter. Hey folks, welcome to the channel. Thanks for joining us. If you're new to this channel, this is my project to put a Nissan Leaf motor into our Porsche 911. So in the last video I was working on building out the adapter card for our open source Inverter Logic Board and getting it installed into the Nissan Leaf Inverter. So it's physically in place, but now we're going to have to take a look and start trying to actually get it wired up, see that it gets data flowing in and out of it, and get it ready so that we can start moving on to testing with the motor pretty soon. So let's go take a look. Alright, so last time we got the adapter board built up, the logic board installed onto it, and then the combined adapter and logic board wired into the inverter. So now we're ready to, I guess, switch it on. As with most things we do on this project, I'm trying to take kind of a sensible step-by-step iterative approach to it with just kind of work through things in a logical manner. So obviously first step is just going to be make sure that we can still switch this on. It worked on the bench, hopefully it'll work in the inverter, and then start to, I guess, send it some data. So do things like send some power to the capacitors, pretty low power to start with, make sure that that's showing up, see if we can send some signals to perhaps a throttle signal or something like that, just see what happens on the software, then attach the motor and see if we can get that spinning. No idea how much we'll get through, how long this is going to take. This is all kind of new ground at the moment, but we'll see where we go. So first step, we're going to send power to the logic board. So it's 12 volts just from a battery I've got here in front of it. Alright, so it looks like the inverter has power going to it and it's alive with the blinking light. There's also power going to the Wi-Fi, so it should be able to connect to the inverter, and then let's see if we can see anything in the data. Alright, so we've now got data coming through on the spot values on the inverter kind of config and monitoring page. The values when we switched it on before were pretty static, but this software has quite a cool feature where you can check certain things and then you can move them into gauges. And as you can see, while these show certain values, they're not 100% static and they are changing and adjusting slightly depending on what signals they get. So these are things like DC voltage and current, AC voltage, temperatures. So we're going to play around with sending some power into the inverter and see what happens to these. So we've got our pre-charge circuit wired in. So let's see if sending some power changes anything. Okay, so no major changes, but nothing blew up yet either, which is a good start. Okay, so we've been trying a few different things here that haven't really been working. Problem is that even though I've got power coming out of the various elements of the pre-charge circuit is not being allowed into the capacitor, and I think that's a software thing. I think it's some sort of restriction, which is, I'm sure, very sensible. But I think one of the reasons is that essentially when I was doing the first part of this work, I had to create my own pre-charge circuit, and I was still trying to do the same thing, doing it outside of the inverter. But the guy who designed this very sensibly and put a pre-charge control in here, so I can do away with some of the stuff that I was going to have to put in place. So I've now wired it up so that the control for the pre-charge circuit and the positive are being triggered from the inverter itself rather than from a separate circuit or by me manually. So basically, as soon as the inverter turns on, pre-charge should switch on, and then as soon as the inverter reaches the designated voltage, the main contact should turn on. So we're going to wire in the relays, get the negative or ground providing power, and then we'll get the inverter to control the positive values. Alright, so now we've got the two positive side relays wired up to the Inverter Logic Board. So the pre-charge one lined up to the pre-charge output, and this lined up to the DC signal output. So when the inverter switches on, this gets switched on for 5 seconds. Then once voltage is reached, this one gets switched over. I've got the ground side going through a contactor as well. That's already up and running. The one thing I don't have is I don't actually have any power coming out of the main contactor yet. I need to make a new cable that's long enough to get to where I need it to go without being dangerous. Alright, here it goes. Let's see what happens. For this test, we're switching on the inverter and then instantly putting power through to the capacitor. See how much of it actually makes it through. So we're showing 1.1 volt, but if we take power off the inverter and just put it through the capacitor, we get the full 50 volts that we're expecting. Kind of manual pre-charge for the rest of these tests. Probably get a little bit of power into it before switching on the inverter, and then we can put it up to whatever the full voltage is that we want to use. The good news is that the logic board is recognizing the voltage, so it's definitely seeing it come in. Alright, so we're going to go with manual pre-charge first, just to see if we can see voltage values changing on the inverter. So I've got a few things showing up as gauges here. The DC voltage isn't actually at 42. I think it's just a scaling thing I'll have to work out. But yeah, let's see what happens when we add some power to the capacitor. And there, I don't know if you saw it, but that's gone right up. So the power that's coming from the batteries is making it through. Alright, so now that we've got a good understanding of the inverter itself, we're going to move on to the next next phase of the process. So as luck would have it, just had the postman turn up with a new accelerator pedal. So the current accelerator pedal in the car is a cable operated one, whereas this is the later model 996 E accelerator pedal. So we're gonna do some digging around with this, figure it out, and see if we can get signals coming from the sender here into the inverter. So this is the, I guess, the processing unit, the signal unit from the accelerator pedal. So that'll hopefully send details that we can use and interpret on the inverter. So got 6 wires in total. Check out the wiring diagram to see what's what, but I just want to dismantle this block connector so I can see exactly what's what. In the end I cut it off. Ultimately we'll wire up our own connections anyway, so I'll use a separate connector that I have both ends for and fits my purpose. But yeah, they're off, so let's take a look at the individual wires. So according to the wiring diagram I've been able to find, we've got a pair of sensors, each with a ground, a 5-volt and a signal wire. For pedal value sensor 1, the signal wire is white, the pink is the ground, and the brown is the plus 5-volt. So I'm just going to connect them in such a way that I can hook them up to the inverter, and we'll see what sort of values we get. Alright, so here we go. We've got the inverter switched on, but no power going into the capacitor, so anything we do shouldn't blow things up. So it's reading its baseline voltage, and then we've got 2 potentiometers, so basically the 2 throttle signals, and they're just showing values. They're an open wire, so who knows what's going on to it. So I'm going to connect the signal wire for the accelerator pedal, which I've already connected the 5-volt and ground to. Let's see what happens. Ooh, okay. So signal has gone down to 0. Let's see if anything happens when we move it. Alright, that was hoping for too much. It's entirely possible I got the wiring wrong. Let's go back to the drawing board. Alright, so I did quite a bit of digging and troubleshooting off camera. It looks like probably when I was soldering or something I managed to screw up the pin that had the 5-volt coming out, and therefore I wasn't able to create a signal that the inverter could understand. So just, I guess, to explain it a bit, so this throttle sensor, we talk about e-throttles and all this sort of thing, but to be honest, they're very, very basic. The sensors themselves are very, very dumb. All the kind of important part happens in the ECU, or in this case on the the inverter board. So this is basically just a potentiometer. So you've got 3 connections, one going to a 5-volt positive, one to ground, and then a signal. And basically it's a variable resistor, and depending on how much voltage comes through the signal wire, which is dependent on what you turn the resistor to, that dictates the values coming through to the inverter, and that tells it's able to figure out how hard you're pressing the accelerator for that. So in order to see this, we need to scroll down here. So we've got the spot values, so these are pulling in the values from the inverter. And if we scroll down, we can see with the two potentiometer values, so pot values, pot 2 doesn't have anything connected, so it's still just pulling a random figure, but pot 1 is pulling 2732 out of 4096, which works out about 2.25 volts. That's what's coming out of it at the moment. So what we can do is we can do two things. One, we're going to make this into a gauge, and we'll come back to that in a moment. And then we're also going to get down ready to do a plot. So if we look at the gauge here, you can see it's showing a value, and then if we turn the piece, it scrolls up. So at the moment this isn't calibrated, so it's going from 0 all the way up to the maximum, so you're only seeing a small movement on the wire. But if we go and start a plot of this value, what you'll see there is it's varying slightly, but it's actually all within a very small range. So if we then turn it, you'll see that goes way higher. And then if we let it out slowly, we'll get a nice gentle decline. So there we've got our values coming through. So there we have it. I need to do a fair bit more testing on this, but I think we're in a pretty good place. We've got the throttle or the accelerator sending data to the inverter, which is fantastic. So we should be able to send signals that will adjust the speed of the motor. And we've also got voltage showing up, so when we send voltage into the capacitor, it is being read by the inverter, which is awesome. Hopefully next time we'll be able to look into trying to maybe even run the motor at low speed on the bench and see how we go. So I'm really starting to get my head around this board and the software that's in it. It's really quite a smart setup, and though I'd done a lot of reading up about it and the software before giving it a go, it was all very theoretical. So it's great to start to see what happens when you start to connect things and you can see values appearing in it. So we're pretty well set up to move on to the next phase, which is where we're going to try and start to get the motor up and running. I'm very happy with how far we've managed to get now that we're actually seeing something, an action that we're taking outside of the inverter actually, causing a change in values within the software. So this sets us up really well for the next stage, which we'll go into in the next video, which is to try and get the motor running and have it actually controlled through the inverter by something that we're doing with the throttle. So thanks for joining us with this video. If you've liked it, please consider subscribing. Feel free to click the notify icon if you want to be told about when we've got new videos. And if you've got any comments or questions, please put them through. I try to answer them as soon as I can. But till then, thanks for joining us, and see you next time.